Hello everyone, welcome to TechnoGate. So today I'm going to discuss the third application of divide and conquer, which is binary search. So there are binary search here. So there are two type of searching are there, linear search and binary search. So we will discuss first on linear search and after that binary search here. So linear search. So input is what? Okay. So an array of n elements here. Okay. So what is the output here? So desired output is find position of x, so an array of an element and element x. Okay, this is searching only. So element x here. So find position of x if x is in array. If x is in array. Otherwise, return -1. So if x is in the array, okay. So find position of x. If x is in the array, then find position. Otherwise, return -1 here. Okay. So let's see this. So here, suppose this is the array here, 10, 20, 30, 1, 2, 3. So here, this is the array here. So x is 20 here, position is what? 2. X is 1 here, position is 4 here. X is 50 here, position is -1. Return. Okay. So this is the concept here. So what will be the time complexity and all the things? So we'll discuss here. So here linear search is a function, make a function linear search. So what will be passing here? This is a name of the array a, comma, number of elements n, comma, searching element x. A, comma, n, comma, x here. Okay. So let's see this one. A, comma, n, comma, x here. So if a of I, so take a loop here. Okay. First of all, take a loop because there are n elements are there. So take a loop a. So here for loop is there for I1, I less than equals to n, I plus plus. So what will happen if a of I equals to x, if a of I equals to x, then return I here. Okay. So suppose that we want to find the 20 here. So 1. Yeah, so a of 1 is x. No. Then in the loop here. I plus 2 here. So a of 2 is 20. Yes. So return 1. Otherwise, return -1 outside the loop here. Return -1. This one here. This is a linear search here. Okay. So what is the time complexity here? So if element is found here, then what is this? Is a successful search. If element is not found here, then it is unsuccessful search. So there are two types of searching. So x is 20 here. This means it is a successful search. Successful searching here. Here again successful searching. Here unsuccessful. Unsuccessful. Okay, successful and unsuccessful. Element found here 20 here, 1 year, but 50 is not there. So if element is there, successful search, otherwise in unsuccessful search. So what is the time complexity in successful search and what is the time complexity in unsuccessful search? Let's see here. Okay, so let's check here. First of all, successful search. So what is the successful search here? So successful search is what? First of best case. So is if element found at the first position only, the element like 15, 20, 10, 3, 1, 2 year. So suppose that we want to search 15 years. So is the first position only. So the first position only, then constant time. So in the best case, for the successful search in the linear search, how much time it will take? Constant. So element found the first position, then simply written. Only constant time loop will be run here. Second one is worst case. Worst case here. So in the worst case, what will happen? We have to search like suppose that 2 year. So we have to go at the last of the array. 2, 1 like that. So is a order of n. It is the order of n here. Okay. It is the order of n here. And third one is what? Average case. So in average case, for first element, one comparison. For second element, there are two comparison. For third element, there are three comparison. For n element, there are n comparisons like that. So here in average case, 1 plus 2 plus 3 up to there are n. Okay, and how many elements there are? N elements are there. So for first element, one element comparison. For second element, two comparison. Third element, n comparison. So what is the average here? So total element divided by n in number of elements. Okay, so what will happen here? n plus 1 by 2 into n. So what is there here? N plus 1 by 2. Okay, this one. So what is this? The theta of n. A theta of n here. So in linear search, best case constant time complexity here, worst case order of n time complexity here, average case here there are n plus 1 by 2. Okay, is theta of n time complexity. It is a successful search. It is a successful search. Suppose that what happened in the unsuccessful search. Okay, so let's say unsuccessful search here. So first one is the best case. So we want to find out the element here 50 here. Here 50 here. So whether it's a best case, whether it is worst case, it is average case. Every time we have to search total array. We have to search a total array here. Okay, total array here. So time complexity is what? Theta of n. Okay, sorry, omega of n. So we have to search total array here up to n last order of n, order of n, order of n here. Second is worst case. Okay, so worst case is, best case is what? There is we have to find out the total array, no element here, 50, no element here, again order of n, total element here. And average case, again theta of n here, again here theta of n. Okay, so omega of n, big of n, and theta of n here. Okay, so unsuccessful means there is no element, so we have to search total array. Okay, whether it is best case, worst case, or average case, no problem. Okay, then in the best case successful search, you have to find 50 here, 15 constant time, worst total array, and best case, and average case theta of n time. Here n plus 1 by 2 comparisons are there. This is a linear search. This is the linear search. So now we will discuss binary search. It's a very important here. So let's check binary search. Binary search. Okay, so binary search is applicable only for the shorted array. only for the sorted array. On unsorted array it is not applicable, only for valid only on the sorted array. Okay, so let's check here. A sorted array of size n and element x, output is what? Find position of x if x is in array, otherwise return -1 here. So it is applicable only for the sorted array. It is applicable only for the sorted array here. So let's check here. Okay, this one here. So here, let's check here. X40 here, what is the position here? 4 here. X50 here, what is the position here? 5 here. X55 here, position is 6 here. And X is 80, then return -1 here. No element is there. So here, it is applicable only for the sorted array. So this is sorted array. This is the sorted array here. Okay. So let's check how to find the time complexity here. Okay. How to find the time complexity here. Let's check one by one here. So this is the application of divide and conquer. You know, this is the application of divide and conquer here. So what will happen here? So we write a code here, binary search. Binary search. So what will you pass here? Is name of the array, start index, last index, and the element we have to find here. Okay, this one. So suppose that if there are only one element is there. Okay, if there are one element is there, suppose only 10 is there. Okay, this one. Okay, so starting index pointing here, last index pointing here. Okay, only one element is there. Okay, and so here if I equals to j here. Okay, only one element is there, but the element is present is a desired element or undesired element here. Suppose you want to search here 20, but here only 10 only. Okay, so we have to check like if a of I equals to x or not. Okay, only one element is there. I know only one element is there, is 10 is present here, but we want to access 20, but 20 is not present here. So we have to check that element is a desired element or not. Okay, so if is there, then always what will happen here? Return I. Okay, else return -1. Okay, -1 here. Clear? Okay, else return -1 here. One element is there, so this one. Okay, now if element is here more than 1 year, so we have to find the else part here. So else part is what? You have to find more than one part here. So if they suppose that there are two elements, 10 and 20 here. Okay, ij here. So we have to find the mid element. So mid of I plus j by 2 here. So we have to find the mid element here. If so, only one element is there. Else, if more than one element are there, then we have to find mid element here. So here mid element is there. Suppose it is 30 here. Suppose that. So 1, 2, 3 here. So 1 plus 3 by 2 is 4 by 2 is 2. So here 20 is present here. So there may be chances that searching element must be present at 20. The searching element may be present at 20 at 2 here. Okay, 20 here. So the searching element may be present at mid position. Searching element may be present at mid position. So here what we will write here, again check if a of mid equals to x. If a of mid equals to x, then what will happen? Return mid position. Return mid position. Okay, return mid position here. Now if we want to search like 30, so 30 is not the mid position, so we have to check mid element is greater than searching element or not. So here else we have to find if a of mid is greater than x. Okay, suppose that this is the array like 10, 50, 20, 25, 35. 1, 2, 3, 4, 5 here. Mid is 1 plus 3, 1 plus 5, 6 here. And we want to search, okay, we want to search here, x is 35. So mid element is greater than x. X is 35, mid is 20, condition is false here. Okay. So if a of mid is greater than x, okay, then suppose that we want to search like 10 here. We want to search 10 here. Okay. So we have to check only this part, left hand side part only. Either at a time we have to go either left hand side or right hand side, because mid, so mid to right or mid to right, only one position only. Okay, either we go to the left or either we go to the right. Only half of the part of the array will skip at every time. Okay, so return here, return binary search. What will return here? A comma, element will be presented at the left hand side here, I comma, okay, mid position is greater than, okay, so mid minus 1 comma x here, mid minus 1 comma x here. Otherwise, if this condition is false here, then what? Suppose that we want to search 35. We want to search 35 here. So 35 is greater than desired element is greater than mid. So condition false, then return binary search a mid plus 1 to j comma x. This is the binary search. This is the binary search code here. Okay, simple this one. Okay, this one close here and this one close here. So this one here, this one close here, and this one here. Okay. So this is the binary search here. So only in binary search, either we go to the left, either we go to the right. Okay. So total array will not be searched, left or right will search, either left or right here. So let's take what is the time complexity. Okay. Let's take here what is the time complexity for binary search here. Okay, so let's check here. So Tn be the time complexity for binary search, then what will happen here? Okay, so if there is only one element is there, okay, is there one element is there, so what will happen here? Constant time, only one comparison is there. One comparison means constant time it will take. So if there is, if n equals to 1 year, only one constant time it will take. Okay, and if n greater than 1 year, if n greater than 1 more than one element, so you have to find mid element, so we'll take constant time. Again we have to compare element whether the mid position or not, constant time here. Again we have to check mid is greater than or less than, constant time. After that, either this n by 2 or this n by 2 element here. So either this will search here or either this will search here. So Tn by 2, either first half or second half. So here constant for calculate the mid, again constant for check mid element is present in mid position or not. Okay, after that compare mid is greater than or less plus Tn by 2 if n is greater than 1 here. So it's a total constant here. So Tn by 2 plus c, what will happen in order of log n. So we already saw this recurrence relation in the previous part here. So time complexity of binary search is what here? Log n. Time complexity of binary search here, log n here. Clear for everyone? So this is the way to find the binary search equation, binary search time complexity, recurrence relation complexity, and all the things. Okay. So let's check some problem. So we will discuss some of the problems, gate problems. So there are third application, linear search as a binary search. Okay. So let's check, discuss worst case, best case time complexity here. So what is the best case time complexity? So best case is what? So whenever up to this one is the constant time it will take. Suppose you want to search 20 year. So it's the best case. So whenever we find the any element which presented the mid position here. So here presented 20 here. So it will take here constant up to this one constant because recursive called done here only. So how much time it will take constant in the best case? Order of one. So remember this one. This is a procedure here. So suppose that we want to search 20, the element which are we want to find out is are present in the mid position. So here constant time. Okay, constant time it will take here. Now worst case is big of log n here and average case theta of n here. This is the time complexity. Oh, sorry, theta of log n. So in the best case, only constant time complexity, otherwise log n complexity here. Okay, this is the way to find the elements. Okay, or find the time complexity recurrence relation in the binary search here. So what is the advantage of binary search here? So advantage of binary search is random access is possible. A very big advantage here, random access is possible. Random access is possible here. So here directly we can go at 35 or either we can go at 10, either we can get, so anywhere we can go here. So random access is possible. So it's a very important part here. Very important part here. Okay. So this is the way in the, so this is third application of the divide and conquer binary search. It's a very important application. So we will discuss binary search problems, find max mean problems, power of element in the next upcoming lecture. Okay. Thank you everyone.